Hello everyone, this is Dr. Vaughn making a video for section 2.2 by request. What I've done is I've taken some of the problems out of my math lab and I've typed them into a Word document. So I'm hoping that this video will serve a couple of purposes. One is give you some additional ideas about working with reference angles and the signs of the different trigonometric functions, but also demonstrating how you can actually type things using the equation editor in Microsoft Word. And I'd like you to consider using this tool for your worked out homework in this week and beyond. Now, if you didn't do it this week, don't go back and redo it. But moving forward, I'd like you to learn how to use this equation editor in Microsoft Word. All right, so we're going to start with problem 1 here. Find the reference angle for negative 108 degrees. So negative 108 degrees is in the third quadrant. So that's we want to find the angle in the first quadrant that has the same relative position to the coordinate axes. So since this is in the third quadrant, if we go 180 degrees, the opposite direction will be in the first quadrant. So if I add 180 degrees to this negative 108, I will get the reference angle. So I'm going to try to type my solution here using a complete sentence. This is another good idea for doing your worked out homework problems. In my math lab, it doesn't matter so much, but the worked out homework, I like you to try to respond with complete sentences. So the reference angle in the first quadrant is, and now we're going to go into the equation editor. So you go to Insert and all the way over here to Equation, and you get this palette full of tools that are very handy for typing things mathematically. So now I'm going to use this script button, and I'm going to write 180 as the base. And then as the exponent, I'm just going to put the degree symbol, this little circle that's right here. Okay, 180 degrees, and then plus the negative or minus. So we'll do a parentheses here. And then inside we'll do the script again. Negative 108 is the base, and then the degree symbol. Okay, and now we're going to add, which is really subtracting, 180 minus 108 and get 72 degrees. Exit out of the equation and I'll put a period for the end of my sentence. All right, so now let's look at problem 4. Find the exact values for the 6 trigonometric functions of the angle minus 120. This might be easiest to do in a table. Three, four, five, 6. Yeah, 6. All right, and inside the table, each table, I'm going to insert this, trigonometric function, sine of negative 120 degrees. And one of the nice things about the equation editor is I can actually copy this entire equation and paste it in these other places. Then I can edit. I can go back and say, okay, next time I want not sine but cosine, and over here I want to put tangent. Over here we'll put the cosecant, secant, and cotangent. All right, so now I want to think about the reference angle. So negative 120, we're going clockwise, starting from the the origin and the positive x-axis, if you will, 0 degree mark, and you're going backwards 120 degrees. So again, you're going to be in the third quadrant. If you add 180 degrees, you're getting a reference angle of 60 degrees. And so we're going to use that reference angle of 60 degrees and find the trigonometric functions and then apply the signs, SIGN, to get the correct values for each of these trig functions over there in that third quadrant. So with using a reference angle of 60 degrees, the sine of 60 degrees is root 3 over 2. And sine in the third quadrant is negative. So my response here is going to be negative root 3 over 2. So I'll do this with the fraction tool. In the numerator of the fraction, I'm going to put negative, and then I'll use my square root tool and put the square root of 3 over 2. Now, the cosine of 60 degrees is 1/2. Again, cosine in the third quadrant is negative, so here I'm going to put negative 1/2. Now, tangent is positive in the third quadrant, and it's the quotient of sine over cosine. Tangent is sine over cosine, so you get this negative root 3 over 1, which over 1/2. The 2's cancel, so the negative, you get just the square root of 3. Now for these other three, we're just going to take the reciprocals of their original functions because of the reciprocal relationship between these. So for the cosecant, I just want to take negative 2 over the square root of 3. I could try copying this over for efficiency and just switch the roles up here of negative. Instead of root 3 on the top, I'm going to put 2. And then instead of 2 on the bottom, I'll do the square root of 3. Now you could rationalize the denominator here and write this as minus 2 root 3 over 3 if you wish. I'm going to leave it with an irrational denominator. The secant is just the reciprocal of negative 1/2, which is going to be negative 2. And I don't even need to typeset that one. I might want to center it in the box here. And then finally, the reciprocal of root 3 is going to be 1 over root 3 or root 3 over 3 if you rationalize the denominator. So this time we'll go ahead and insert that rationalized denominator since I have to redo this one anyway. So in the numerator, I'll say square root of 3 over 3. All right. Now for problem 10, find all values of theta in the interval 0 to 360 that have the value sine of theta is equal to minus 1/2. So the sine function is negative in the third and fourth quadrant. So these are going to be angles that are between 180 and 360. And then the other thing that I'm going to look at is that the reference angle, the sine of 30 degrees, is 1/2. And so I'm going to find the corresponding angles in the third and fourth quadrant that have that same reference angle of 30 degrees. So this is going to be 180 plus 30 when you get into that third quadrant, which is going to be 210. The values of theta, so let's just go ahead and copy this part. In the third and fourth quadrant are theta equals 210 degrees. And then we're going to go all the way over to just short of 360, actually. So 30 degrees back from 360. Which is 330. One of the things I keep in mind when I'm doing problems like this is just the graph of a sine function, the understanding of exactly where those reference angles are. And so if I go 30 degrees back from 0, that's backwards from 0 or clockwise from 0, that's where I'm getting that 330, which has the the negative value of the same positive 30 degrees on the other side, the reference angle. And then also I'm just kind of going upwards or backwards from 180. So I'm visualizing where that angle is in my mind, and then I'm either adding to 180 or subtracting from 180, or adding to 0 or subtracting from 0, or adding to 360 or subtracting from 360, whichever it might be. So, first find the reference angle and then make the adjustment to one of those sides based upon the quadrant that has the correct signs. All right, and last problem for this video, number 14. Suppose theta is in the interval from 90 to 180. Okay, so that means that it's in the third quadrant, and they want to find the sine of the SIN, sine of that same angle plus 180. So since the original angle is in the third quadrant, when you add 180 degrees, that puts you back over into the first quadrant, and that angle will be positive. Sine is positive in the first quadrant. So since the original angle is in the third quadrant, when we add 180 degrees, we are back in the first quadrant, and the sine of the sine function is always positive. There you go, and I didn't even have to use the equation editor. All right, I hope this video has been helpful to you. I'll talk to you next time.